The table shows values for a function f at selected values of x. So -2, -1, 0, 1, 2, 9, 4, 101. Ooh, it's not linear. And it looks like that's what we're supposed to do. I think I gave that away. Which of the following claim and explanation statements best fit these data? Well, it's not linear. And the reason why I know it's not linear is it went from 9 to 4 to 1 to 0 to 1, which means, if I repeat 1 here, it's not a straight line. But what you're supposed to do is you're supposed to go to your graph and you're supposed to find the rate of change. The first round of you finding the rate of change would determine whether or not something is linear. For example, what I'm going to do is I'm going to find out that to get from 9 to 4, we subtract 5. And to get from 4 to 1, we subtract 3. And 1 to 0, we subtract 1. And 0 to 1, we add 1. So since the rate of change is not a constant number throughout, it is not linear. Okay, if all of these numbers were the same, it would be linear. That's not what happened here. It's not linear. So maybe it's quadratic. And it looks like that's going to be my only option, but we need to make sure we explain it well. Okay, if I were to do the same exact process again, I need to end up with the same number. To get from -5 to -3, you add 2. To get from -3 to -1, you add 2. To get from -1 to +1, you add 2. So since the quadratic, or the rate of change of the rate of change, is the same constant number, we have a quadratic. So again, that phrase that I just said is every time you do a round of these, you are doing a rate of change. So the rate of change of the rate of change is a constant number. So this is a quadratic function because the rate of change over consecutive equal length input value intervals is constant. Well, that's not what I said. I said rate of change twice. So f is best modeled by a quadratic function because the change in the average rates of change over consecutive equal length input value intervals is constant. So the change of the rates of change, so change of change, oh boy. So lots of words there. But D is quadratic, and it tells me change of a rate of change, which means quadratic. So if it was cubic, it would be change of the rate of change of the rate of change, and you look for change 3 times. Looking for change 3 times sounds like I need to vacuum out my car, and I need to find money, and I look for change. Hope this helps.